Hello everyone, Standard 9, Subject Maths, Chapter number 2, Polynomials, Part 1. Okay, before we start with the polynomials, let's just understand what is algebraic equations. Okay, equations or my expressions. Okay, algebraic expressions or say equations. Now you have already studied in your earlier standard about remainder theorems, algebraic identities like x plus 1 to the power square. So this one is by algebraic identity only, one identity. So when you split it, it's x square plus 2x plus 1. One thing you observe in this expression is there is one variable and some constants are there. There is one variable and constants are there. Now, so we know that algebraic expressions, it's nothing but my constant into a variable n. Here some powers were given. So variable power any rational number. Any rational number. Okay. So here the term comes a constant and variable. Now let's understand what is constant and what is variable. Let's say a date in a month of January. A month of. Now the date in a month of January. Okay, so it starts from 1. Now the year is 2021. Now 2, 1, 2021. 3, 1, 2021, and so on up to 31st 1, 2021. Now look at over here. What remain constant? What is varying? It means variable. It means something which is varying, continuously varying. So my month is remain constant and my year is also remain constant. Okay, but what is varying? Days 1, 2, 3, 4 up to 31st. So things which remain constant, or we can say it does not change, we say that there is a constant, and things which are keeps on changing, we call it a variable. Okay, so my algebraic expression, instead of writing this one, Which number? Whole number. Okay. When someone asks you, find which are the polynomials. For example, say I'm taking 2x plus 1. Okay. X plus 1 to the whole square divided with x plus x minus 1. Look at over here. Now, the fourth one example, I'm taking x square plus 3x plus 1. Not this one. Say x square plus 2x plus 1. Here is x plus 1. The fifth one, I'm taking x plus 1, x minus 1, x plus 1, x minus 1. The sixth one, x square plus 4x plus 2. Okay, look at this example. Okay, so we have to identify which polynomials is, which example is a polynomial. So definition says if polynomials equals to constant into variable with some power whole number. Okay, the variable power should be my whole number. Now look at this one example. Here my constant is there, which is 2, and x is my variable plus 1, any constant. Okay, now look at over here. What is the power of this variable? What is the power of this variable? It's 1 only. Okay, so 1 is my whole number. So we are just checking the variable's power. Okay, the variable power is most important. If it is whole number, then it's a polynomial. So this one is my polynomial. Now look at this example. Okay, look at this example. So when you solve this one, x plus 1 to the power 2. If I am taking this denominator into the numerator, what will it become? X minus 1 to the power minus 1. Now look at over here. Now the power I'm getting in a x is minus 1. What I am getting over here? When I split this one, the power of x, it should be minus 1, and minus 1 is not whole number. So we can say that this is a not polynomial. Now look at this example. See, again, if you take this term into the numerator, it becomes a negative. Now look at over here. Okay, just split this one. Okay, so what will x plus 1 to the whole square in denominator, x plus 1. Okay, so the 1 gets cancelled. What remains? X plus 1. After simplifying this one, what I'll get? X plus 1. X plus 1. Okay, so we can say that this fourth one is my polynomial. Okay, first we just simplify it, whether the forms I'm getting in a polynomial form or not. If I'm getting this term in a polynomial form, then we can say that it's a polynomial. Now look at this example. Again you take into the numerator, the power should be x minus 1. It does not get cancel anything. So we can say that it's a not polynomial. Okay, now observe this example. X square plus 4x plus 2. There is nothing given in a denominator, and the power of x are my whole number, here 2, here 1. Okay, so this one is the polynomial. Okay, what if say 3 root x plus 1. Is it a polynomial? No, it's not a polynomial. Why? Because x power is 1/2 and 1/2 is not my whole number. So we can say this one is a not polynomial. Okay. Now let's take one more example to understand. If I'm taking one more example, say 7/3 into x square minus 1. Is it a polynomial? Yes. See, we are not talking about constant. We only seeing its a variable's power. Okay. If it is whole number, we can directly say it's a polynomial. Okay. This remains constant. It does not make any difference. Okay. It does not change over here. So this one is my polynomial. Now you get it. What is polynomial? What is important? Okay. Constant can be anything. We just see that variable power should be a whole number. When you simplify it, you get the variable power whole number. We can say that this one is the polynomial. Okay. Now, we are continuously talking about constant and variable. When we combine this constant and variable, we get a term. What we will get? We get a term. Okay. For example, now term. The word term. When we combine constant and variable, we get a term. For example, says 3x square plus 2x plus 1. Okay. Now look at over here. Here 3x square and 2x and 1. I'm just combining 3 and x square. I'm getting a one term, second term and third term over here. So how many terms are there? We can say there are 3 terms. How many terms? 3 terms. See, here 1 is given. It doesn't mean that variable is not there. See, if it is nothing written over here, whole number, so it can be expressed x to the power 0, and we know that x something power 0, it always 1. Okay, so I am not writing x 1 dot x to the power 0 because it's I am getting 1 only over here. Okay, so we can say this one is my third term. So how many terms are there? 3 terms. Okay, now each terms are separated with only 2 signs. First one is addition and the second one is the subtraction. So there are 3 terms. Let's take one more example. Say 5x minus 1, 5x square minus 6x plus 1. Now look at over here. How many terms are there? My first term, second term and third term. 3 terms again. 3 terms are there. Okay. So 7x. How many terms are there? 1 term. 1 term. Say x square minus 1. How many terms are there? 2 terms, 1 term and second term. These both terms are separated with which sign? Negative sign. 2 terms. Okay, so the term says a constant and it's a combination either plus or negative with a plus sign and negative sign. Okay. In some example, either both pair occurs or only the plus occurs, only the minus occurs. But the difference is the term only separated with this two, only separated with the plus and negative sign. Let's take one more example. Okay, and check whether this one is a term, how many terms are there. Okay, say 4x square plus 3x plus 5 plus 1. As you can see, how many terms are there? Does it 4? No. What I am saying is the terms are only separated with only two signs, negative or positive, positive or negative, only two signs. So I am taking this 3x into 5 as a one term, So when I am simplifying this 4x square, I am getting this 3 5s are 15x plus 1. Now you can see how many terms. There are 3 terms. There are 3 terms only. Now take one more example. Say 3 by x square plus 2x, no, let's take minus, plus 1 x square. Now, so the x minus 1. Can you identify how many terms are there? How many terms are there? First, we are going to simplify it. What? We are going to simplify it. So I am getting x minus 2, x minus 1 whole square, x minus 1, it gets cancelled, x minus 1. Okay, so there are only 2 terms. There are only 2 terms. Okay, now note it down all these examples. Okay. All these things we are talking in a one variable. Okay. So my topic, all these topics are comes under a polynomial of one variable only. Now, when I am talking about terms, each terms are separated with plus sign or negative sign. Okay. So each term have some coefficient. Each term I'm saying that each term have some coefficient. Okay. Let's take example. Say 3x square minus 2x plus 1. Okay. So, can you identify how many terms are there? There are 3 terms. I'm saying that each term it means my first term is 3x square, second term is 2x, and the third term is 1. Each term has coefficient. Each term have coefficient. Okay, each term have coefficient. So, the solution you can write that x square's coefficient square, the coefficient of x square is 3. The coefficient of x square is variable part, and this C is my constant. We can say it's a coefficient part. Okay, so whatever is it multiplied with a variable, we can say it's a coefficient of that variable. Okay, the coefficient of that variable. So the coefficient of x square is 3. Now the coefficient of x is 2. The coefficient of, there is no variable, you can write the coefficient of x to the power 0 is 1, x to the power 0 is 1. Okay, so this way we can find the coefficient of each terms. Now let's move on. See, I'm saying that 3, 2 and 1. Okay, all are the coefficient of x square, x and x to the power 0. Okay, it doesn't mean that these are not polynomials. Okay, these are my constant polynomial. Which polynomial? Constant polynomial. This 3, 2, 1 all are my constant polynomial. If somewhere written a 0, it means it's my 0 polynomial. We call it a 0 polynomial. Okay. The next thing is the variable in a polynomial is x. The next thing is variable in a polynomial x. It means my whole expression contains only one variable, which is x. So we denote it with p of x. Okay, p of x. So variable is polynomial x. Then p of x we denote. For example, say x square minus 2x plus 1. So this one, it's my variable x content. So this one we can write p of x. If y square minus plus 2y plus 1, then we can write it's a variable. It's a variable in polynomial is y. My variable in polynomial is y. It can be anywhere. It can be anything. You can write x, y, z, any small alphabets. Okay. Either it can be z plus 1. So the variable in polynomial is p of z. Okay. Here we are talking about the polynomial in one variable. It means my whole expressions contain only one variable. Either it can be x, y or z. It can be anything. Okay. But to express this variable in polynomial of x, or you can say y or z, x, y, whatever, it's in a form of this one. If my whole expressions contain x, so I am writing p of x. My whole expression containing y, I am writing p of y. Whole expression containing only z, I am writing p of z. Okay. Now, we talk about what is polynomial. We have seen what is polynomial. Okay. What is constant? What is variable? What is term? What is coefficient? How to denote variable in polynomial of any x, y, z. Okay. what we have learned, what is polynomial, terms, coefficient, how to denote that p of x. Now the third thing is degree of polynomial. Degree of polynomial. Okay, so the degree of polynomial says it's nothing but a highest power of variable, that is the degree of that polynomial. For example, you can just highest power of variable, we call it its degree of polynomial. Okay, we call it its degree of polynomial. For example, say x to the power 7 plus 5x cube plus 7x square plus x plus 3. See, this is my expression. Okay, so what the degrees definition here says, the highest power of variable. In this expression we see which variable contains the highest power, which variable contains the highest power among all these expressions. Okay, so now we can go ahead. X to the power 7, okay, x to the power cube square to the power 1. So the highest power is 7. So the degree of this polynomial is 7. So the degree is 7. Let's take one more example. Say x to the power 3 2x plus 1. Can you identify which variable contains the highest power? X to the power 3, the first term only now. So any other element who contains more than 3? No. So we can say here that 3 is the degree of this polynomial. 3 is the degree of this polynomial. So the degree is 3. So the degree is 3. Now question number 3. So x to the power 7 plus x to the power 5, say 4x square plus 1, x to the power say 4. Okay, first we check which expressions contain the highest power. Obviously 7. But look, we can able to simplify it because in the denominator x to the power is 4. So cut it down. What left is x to the power 3. Now you can check which variable contains the highest power. Okay, so my second variable x to the power 5. Here x to the power I am getting is 3. Firstly 7, then I cut it down with this denominator. So remaining is x to the power 3. So what is the degree is 5. I am getting the 5. Understood how to solve this one? Take one more example. I am taking that x minus, say x minus 1, x plus 1, okay, x minus 1. In denominator x minus 1 whole square, x minus 1 whole square 1 to the power 1 square. Okay, so much of questions. So my question is x minus 1 into x minus 1 to the power square, x minus 1, x plus 1. Oh, there are only x minus 1. Oh, the x contains only one power? No. First we simplify and then check. So x minus 1 cancel. X plus 1 and 1 gets cancelled. What remains? X plus 1, x minus 1. Now solve this one. The highest power you get after solving this one. So just doing the multiplication. You already learned how to multiply these two algebraic expressions. Okay. So x square minus x plus x minus 1. This one gets cancelled. X square minus 1. So I am saying that the degree of this polynomial is 2 only after simplifying this one. So the degree is 2. See, while solving this type of question, first we see whether we can able to simplify it or not. Second thing we check is whether this one is the polynomial or not. If it is not polynomial, then it's worth to find its degree. Okay. If it is not polynomial, so why are we wasting our time to find its degree? Okay. So the second thing we check the polynomials. If it is polynomial, then check how to. So okay, which variables contain the highest power? Which variable contains the highest power? The highest power of variable is the degree of that polynomial. Okay, now understand. Okay, so the next thing we are going to learn